Hello guys, welcome back to chapter 17, acid, bases and salt preparations. Today we're going to talk about the second part of chapter 17, okay? Alright, in this video we're going to first discuss about how to predict the solubility of ionic compounds in water, and then we will have to be able to describe experiments to prepare pure dry sample of soluble salts and insoluble salts. Now this is very important in your IGCSE chemistry exams because they will ask you to write down laboratory procedures and to describe experiments to prepare different types of salts. Okay, so to know the preparation method for salts, you need to know whether they are soluble or insoluble in water. Now the diagram here or the table here is a guideline or a map to see which salts are soluble or not. So you need to be able to remember this table, but there is a method, okay, which makes all of this easier than it should be. Alright, so if we take a look at this, you will notice here that all nitrates or all nitrate salts are soluble in water. Okay, so they are all soluble. So, and all ammonium, potassium, and sodium are compounds which are soluble salts. And as for chlorides, almost all of them are soluble except lead and silver chlorides. And as for sulfates, all sulfates are soluble except barium, calcium, lead, and silver. Reason why lead and silver is not soluble can be related to their position in the reactivity series, which is almost at the bottom part of the reactivity series. Now, as for the carbonates and hydroxides, most of them are insoluble except the usual ones such as ammonium, potassium, and sodium. They are soluble, but other carbonates and hydroxides are insoluble. So please spend 5 to 10 minutes per day for about a week, and you'll be able to recognize all of these at the tip of your finger. Okay, it is advisable to do so. Now, describe an experiment to prepare pure dry sample of soluble salts starting from an acid and an alkali. So to prepare soluble salts, we need to first identify what metals do we have. Okay, so if it was sodium, potassium, and ammonium ions, they are very reactive in nature. Okay, and they are very reactive, and all of their compounds are soluble. So meaning that we have to use a different method. So for them, we're going to use acid-base titration, which I'll discuss in a few minutes. And for metals, except sodium, potassium, and ammonium ions, we can use these three equations to know what laboratory procedure that we are going to use. Okay, so if it is for the medium reactivity metals such as iron, zinc, carbon, aluminum, and magnesium, we can simply use metal plus acid reacts to give salt plus hydrogen. Okay, but for the very less reactive metals below hydrogen, which is copper, silver, and gold, we need to have a metal oxide and to react with acid to produce the salt that we want. Okay, I already discussed about this in the last video as well. So reason why the starting materials are different for metals is because of their reactivity. Okay, because if you want a copper 2 sulfate salt, okay, if you want a CuSO4 salt, remember that you have to start from metal oxide CuO. But if you want a magnesium sulfate salt such as MgSO4, remember that you can simply start at your simple metal, which is at Mg. Alright, okay. So this is the laboratory procedure that you can use for any soluble salts for metals which are not sodium, potassium, or ammonium. So we call this the crystallization method. You learned about this back in unit 1 as well, but we'll see a tiny more details here. Okay, so first what we would do is add excess metal or metal oxide or metal carbonate to acid. Okay, this is your step 1. Afterwards, you will either heat and stir it to dissolve the metal. Okay, I'm going to put metal, but this could be metal, metal oxide, or metal carbonate, okay, in the acid. Now you're trying to dissolve this, right? But you will notice that you will have some undissolved excess metals. So you're going to remove this excess metal by a simple filtering method. And afterwards, whatever solution that you are left with, you will heat the solution to evaporate some of the water and then leave it to cool down. So for step number 3 and 4, I want to focus a bit here, okay? We're not trying to evaporate the entire filtrate, okay, to complete dryness, because if you try to like burn all of the water or boil all of the water, it will produce us powders, okay. Anhydrous means without water, so powders without waters. So we need to naturally let it cool down to produce crystals. And but still you need to evaporate some of the water, or else it will take a long time, okay. But some water is the word that is the key word that you need to mention, okay. You're not trying to dry it completely. All right, so heat the solution to evaporate some water and then leave it to cool down. And then after some period of time, you can dry your crystals by either using a filter paper or leaving it in a warm oven, or by using a towel. All right. So again, if it is for any metals here, okay, magnesium, aluminum, carbon, zinc, iron, okay, for all of these metals here, they can come in here, okay. Doesn't matter for metals. So for metal oxide, it could be copper, silver, gold, okay. Let's just say copper is the most common one that they normally ask. So try to replace all of this, and then as a practice, you should write down, instead of metal or metal oxide, try to write down chemical names by replacing the metal or metal oxide that I have put here. All right. So to prepare a dry sample of soluble salt, starting from acid and alkali for sodium, potassium, and ammonium, okay, you might think that, oh, this looks so long and whatnot, but it actually is not. We are simply going to do acid-base titration, but I would like to first talk about why we need to do titration, because the problem here is that all compounds of sodium, potassium, and ammonium, they are all soluble in water, okay. If you remember our first table that we discussed, so the solid that you add, right, to the acid, it would not only react with the acid, but even if you have excess solid, right, it would still dissolve in the water present, meaning that unlike our previous experiment where we were able to see an excess metal, right? For sodium, potassium, and ammonium, we won't be able to see that excess metal, so we can't filter it out, okay? That's why we need to use the titration method, which will help us to find out exactly how much acid we need to react with the base to make the salt that we want, okay. So for example, let's say I want to produce sodium sulfate, okay. Let's say if I want to produce sodium sulfate, I simply can't react sodium with sulfuric acid because they are very reactive. Sodium is very reactive and the reaction will be very explosive and dangerous, okay. That's why I need to use an alkali, which is sodium hydroxide, okay. The equation you have learned before in the previous chapter. So essentially, the entire acid-base titration works on the first idea. You're going to add your base, which is a metal hydroxide or metal carbonate, in this case sodium hydroxide, to acid, which is sulfuric acid, because we're trying to produce sodium sulfate here. So the first step would be to put about 25 centimeter cube of sodium hydroxide, your base or alkali, into a conical flask using a pipette. And since sodium hydroxide is colorless, so do know that it has base properties, or do know that it is sodium hydroxide base, we will add the phenolphthalein indicator, okay. So phenolphthalein, if you remember, in alkali it shows the pink color, okay. when it is alkali. Alright, afterwards, we're going to put our sulfuric acid into the pipette. The sulfuric acid will be put into the burette here, okay? And whatever amount that you fill in, try to record your initial volume, okay? This will become useful later. So what you will do is, by opening this tab, we keep adding this acid from the burette slowly, drop by drop, until the base, the NaOH here, because we put the indicator inside, it is pink now, so it goes from pink to colorless. Okay, so when it goes from pink to colorless, we know that our acid base has been neutralized. So keep adding the acid from the burette slowly, drop by drop, until the base NaOH, which has the phenolphthalein indicator, becomes colorless. Okay, it becomes colorless because, remember, phenolphthalein, when it is neutralized, it gives you colorless. All right, and record the, so as soon as this NaOH becomes colorless, stop this bar, okay, and you will have your final volume here, and you started with your initial volume here. So let's say if your initial volume was around 20 and your final reading is around 40, you know that the amount of acid H2SO4 that you added was 20 centimeter cubes. Okay, so fourth step would be to find out how much acid was added by subtracting the initial reading from the final reading, and from this you know how much volume of acid that you needed to neutralize the base. Now, since we already know this, okay, which is essentially what we want to do, but this time we're going to repeat the entire experiment, but this time without the indicator, because why? Indicator, the phenolphthalein, it is an impurity, okay, when you prepare your salt, because when you have sodium sulfate salt, you can't have phenolphthalein indicator inside. Okay, so repeat the entire experiment without the indicator, and when you have your solution, it is simply the same as before. We are simply going to do crystallization. Okay, so we will try to heat it, heat some of the water off, so some of the water will be evaporated, and then we will let it naturally cool down, so leave the solution to dry and cool down, and after some time crystals will be formed, and you can try the crystals by leaving it in a warm oven or using a filter paper or a towel like we normally would. Okay, and if you are still unclear on my explanation, please try to YouTube or Google the acid-base titration videos, and when you see an on-hand video tutorial, you will definitely understand what I'm trying to say here. Alright, so now comes to the insoluble salt part. Okay, so if we want to prepare an insoluble salt, okay, which is essentially all of these salts. Okay, so these are the insoluble salts here. All right, so if we want to prepare the insoluble salts, we need to mix two solutions containing soluble salts. Remember, we need to mix two solutions which contain soluble salts. For example, our insoluble salt here is barium sulfate. So in exam, if they tell you, oh, prepare a solution of barium sulfate, you need to be able to know that your barium sulfate here is here, right? So meaning that it is insoluble. So to prepare a barium sulfate solution, you need two compounds which are soluble salts. So as a rule of thumb, I have tried to hint it here. You can always use this information. Please use it and make your life easier. Okay, because we know what? We know that all nitrates are soluble. We know that all sodium, potassium, and ammonium salts are soluble. Is it not true? Let's go back and look at this. So all of the nitrates are soluble, and then all of the ammonium, potassium, and sodium are soluble. Okay, just like that I have shown here. So we can simply pick one of these and one of these. Okay, so you will see what I'm saying here. All right, so in order to get, so insoluble salt is barium sulfate. So in barium sulfate, you are already familiar that Ba is a metal cation with an 2 plus, and SO4 is a non-metal anion with an SO4 2 minus. Okay, so what we will do is we need to tell them what two compounds that we are going to mix. So the first compound is attach the nitrate to the metal cation part, because why? Nitrate is NO3 minus, so attach your nitrate to the metal part. So it will be, we will mix barium nitrate, okay, BnO3 twice, and this for the second compound, attach either sodium, potassium, or ammonium to the non-metal anion part. In this case, if we take sodium as our example, it would simply be sodium sulfate Na2SO4. So we'll be mixing barium nitrate and sodium sulfate, and from the equation, if we write it down, you will notice that Ba and SO4 will combine to form a precipitate of barium sulfate. As for the laboratory procedure, it is pretty simple. So BaSO4 here, right? So this is BaSO4. The compound that I've decided to use here is barium nitrate, because why? Attach NO3 nitrate to the metal part and attach either sodium, potassium, or NH4 plus to your anion. Okay, so you know your first compound, you know your second compound. Okay, so when we try to mix it in the step 1 here as shown, so two solutions of soluble substance are mixed together in a beaker, and an insoluble precipitate will be formed here. Okay, it will be insoluble salt will be formed here. So what we are trying to do is bring this entire beaker to here, and then use a filter funnel, use a filter paper, and try to just filter off. Okay, so the second step is described as filter the insoluble precipitate salt, BaSO4. Now, we might have some impurities for the insoluble salts, okay, because we didn't heat it or anything. So when we have our filtrate here, right, this might be impure, so we need to wash it again and again with deionized or distilled water. Now for precipitation, right, when you're preparing insoluble salt and trying to do precipitation reaction, step 3 is very important, because your salt might be impure and you always need to wash it with distilled or deionized water, just to make sure that the filtrate is not contaminated with anything. Now in the final step, just because we're trying to find dry sample all the time, use a filter paper, leave it in a warm place, use a towel, similar process as before. You need to dry your crystal. Alright, so that's essentially how you prepare a soluble salt and insoluble salt. Okay, now let's take a look at this. In exam, a question comes up to you. Try to describe how you would prepare potassium sulfate salt, right? So simply do it very slowly, step by step. Okay, so first of all, you know that since it is a K, right, potassium, so you know that all salts of potassium are soluble. So first write down, or just gist down, that it's a soluble salt. But then under soluble we have Na, K, and NH4 plus, and all the other metals which are not sodium, potassium, or metals, or ammonium. So as I have mentioned before, if it was one of these three, we need to use an acid-base titration method. Now, in order to make a titration happen, you need an acid and you need a base. Since we are trying to produce a sulfate salt here, our acid is simply going to be H2SO4. Our base is going to be potassium, but it cannot be potassium only, because potassium is very reactive. It's explosive. That's why if it is within one of these three, we can either attach it with OH minus or carbonate ions. Okay, So my base could be potassium hydroxide or potassium carbonate. Okay, and if I write down the equation for this, it would be potassium hydroxide plus sulfuric acid would give you potassium sulfate plus water. Okay, this is the equation that we are going to look for. And in the exam, if they ask you to describe, right, if the word describe the experiment comes up, you need to be able to describe it in this way. Okay, just write it in your own version, okay, if you can as well, and maybe summarize it. Normally they give around 4 marks. Okay, so try to juggle your time and then try to put the keywords inside there as much as you can. Alright, and as for the zinc chloride salt, so right now we know that it is a metal and it is zinc. Okay, so it's medium reactivity, so meaning that it falls under, okay, so we know that it is falling under this metal category. So we can simply try to prepare it by using the formula metal plus acid reacts to give salt plus hydrogen, as our previous video taught us. Okay, so it would simply be zinc plus acid is HCl, because this is a chloride, will give us zinc chloride plus hydrogen. So you should know that since you don't need anything special here, this is simply going to be a crystallization reaction. Okay, if they ask you to describe the experiment to produce zinc chloride salt, you should go and describe your crystallization, which is this one. Alright. Okay. Now, if it was calcium carbonate salt, you know that almost all carbonates are insoluble except these 3. Okay, so we know that it is insoluble. So when it is insoluble, the only method that we can use is precipitation. So as I was mentioning before, in order to do precipitation, you need 2 compounds. Your first compound and your second compound. The hint or the information that I want you to use is attach a nitrate and attach one of these 3. Okay, so what you will do is calcium carbonate, right? So it is Ca2 plus and CO3 2 minus. Alright, so what you will do is attach your nitrate to the metal cation. So your first compound would be CaNO3. Your second compound, you can select any one of these and attach it to your negative ion. Let's say potassium, right? So you can attach it to carbonate. So it will be K2CO3. Now if these 2 reacts, we will form an insoluble precipitate of calcium carbonate here. Okay? Alright, calcium carbonate and potassium nitrate. Alright, so I hope that in exam, after watching this video, when you are asked to prepare a salt, you are able to describe the laboratory procedures as well as writing down the equations. Rewatch this video if you are unclear on how to prepare the salts, and when you know for potassium sulfate, zinc chloride and calcium carbonate, right, try to write down laboratory procedures for each of them. Alright, to practice yourselves better. If you don't write it down in exam, most probably you won't be able to write it down. Okay, so practice before you go into your tutorials or exams. Alright, that is all for today's lesson. I hope that as usual you find it useful, and I'll see you again in the next chapter.